if I want to know where these two equations are going to be the same, I can graph both of them on the same set of axes and look to see where they cross. So at the start, I had to actually set up 4 different sets of axes. This is what we're going to use the first one for. So write this system of equations down. We call it a system because these equations are actually related to each other. That's partly what this curly bracket on the side is showing us. It says that these are related. And so what I'd like you to do then, after you write down that system, graph both equations on the same set of axes. So if we're going to solve this now by graphing, I need to graph both of these equations. So for that first one, I got y minus 7 equals 3x minus 4. This is point slope form. So the first thing I do is I plot the point. Now the minus 7 moves it which way? Up, down, left, or right? It's with the y, so that means it's going up or down. And does y minus 7 over there mean up or down? Up. Now, as a little side note here, that's actually consistent with what we learned previously about the absolute value, because with the absolute value, we have the 7 over here, whatever the number is over there, in which case, if we had moved it, it would have been a plus 7 and would have been up 7. Plus goes up. Okay, back to our problem here. The minus 4, it's in with x, so that means it's going to be moving it over in the x direction. Which way does a minus 4 move it, left or right? Moves it to the right. That is right. And so the first thing I do is I go up 7, right 4, and I put a point there. And then that's the point. So now the slope of point slope, my slope is 3, which means that's the same as 3 over 1. Rise over run. So that means go up 3 over 1. And I can just keep following that same pattern to put in all the different points and use a straight edge to draw the line in that goes through all of those points. We'll worry about what that line looks like here in a moment. All right, now let's go on to the second one. We got y equals 2x minus 4. The minus 4 hanging on the end here, which way does that move it? Up, down, left, or right? Down, absolutely. So I start by putting my first point for this one, down 4. And then again, I use my slope. In this case, my slope is 2. So like 2 over 1. So from that point, I go up 2 over 1, up 2 over 1, and I can just keep going up 2 over 1 all the way along. Do that on both sides, and you can make the graph that goes through those. You should end up with a graph that looks like this. Now notice the necessity of taking real care in making the graph. These graphs are actually fairly similar to each other, right? The slopes are kind of close to each other. If you moved one of these lines just a little bit over, it might be hard to tell where they crossed. And where they cross is absolutely essential here. So that's part of being super careful with how we draw these in. All right, now it asks us to solve this. So the solution is where they cross. So the coordinates of that point are, well, x first, so that's 1, comma, negative 2. The solution is the coordinates of that point, both x and y. So our answer here is 1, negative 2. So for this one, we're again going to solve the system. And yes, we are going to solve it by graphing here. So first up, we got y equals 1/3 x minus 3. So the minus 3 tells me start by going down 3 on my y-axis. And then the slope of 1/3 means you go up 1 over 3 from there. And we can just keep going up 1 over 3 in order to be able to figure out where that line is going to go. Put the points all the way out. You notice I just keep making the points? That's partly so that when it comes time to draw the line in, I have some points that are a long ways away from each other, and when I lay down the ruler, I'm going to be more accurate. It's a lot harder to be accurate when I'm just going between 2 points close to each other than when I'm going between 2 points that are a long ways away from each other. All right, and then I'll draw the line in through that to get my line. And then I go to the second one, y equals the absolute value of x minus 2 minus 5. This is following up on that brand new material that we talked about on Monday. So for this one, what does the minus 2 do? It moves it which direction? Up, down, left, or right?
Right.
To the right, absolutely. So this is going to go right 2. And the minus 5 is going to move it where? Up, down, left, or right? Down. And so I go right 2, down 5, plot a point there. Now it's absolute value. So what's the shape of this graph going to be? It's going to be the V shape. And since there's no stretch or anything, that means I'm going to go over 1, up 1 on both sides in order to make that V. And then having done that, we can now start thinking about solutions. And in this particular case, the word solutions is especially useful, being plural, because this one actually, notice, has two different solutions, because there are 2 points where our graphs cross. And so I'm going to need to actually provide both of those. So our first one here, notice that point, it's not over at all, so x-coordinate is 0, but it is down 3, so it's at 0, -3 for our first solution. The second solution, over here. So we get the coordinates at that point. Our x-coordinate there is going to be 6. Our y-coordinate there is down 1, so it's 6, -1. So then those are our two solutions that we need to include on this problem. All right, so in order to solve this one, again, we are graphing. So I'm going to graph that first one, absolute value of x plus 1 minus 8. The plus 1 tells me to go left 1. The minus 8 tells me to go down 8. So I go left 1, down 8, first point there. And then from there, it's just a plain old absolute value graph. So I'm going to go up 1 over 1 on both sides. And then draw the rest of the graph in with a ruler. You're going to have your graph of the first one. Then for the second one, though, we got to do a little bit more work because it's in standard form right now. And typically when you have the equation in standard form, what you want to do is you want to complete these 2 points. You have something, comma 0, and you have 0, comma something. That's going to be our x-intercept and our y-intercept. So let's actually figure out what these are. If I take 0 and plug it in for the y value, because that's what that's saying there, is that y is 0, then notice that term basically has disappeared. So we have 3x equals 18. If 3x equals 18, what does x equal? 6. Because if 3x equals 18, we divide both sides by 3, x equals 6. So that tells me that I have the point 6, 0 on that graph. Now repeat the process for the other one. In this case, notice the x-coordinate is 0. So I go up here, I put 0 in for x, which leaves me with -2y equals 18. And so if I take 18 and divide it by -2, it gives me -9. Yep. And so then that gives me the point 0, -9. All right, now that I have those 2 points found, I can go ahead and use those on my graph. So I have like the point 6, 0. So we go to the point 6, 0. Then I have 0, -9, so 0, -9. Remember, those are 2 separate points. That's why I like to write it like this whenever I do that work. Because every now and then somebody will just write down 6 and -9. And when they do that, it makes it look like a coordinate pair. Like one of them is x and the other one's y. Throws some things off. So I always write them as the coordinate pairs to avoid that mistake. And then once you have those 2 points, then go ahead and connect them with the line. Because if we know 2 points on the graph, that's all we need in order to draw the line in through them. All right, having done that, we now can actually worry about our answer for this problem. Because our answer, of course, is where they cross, and in this case, notice they only cross once. So already you've seen sometimes they cross twice, sometimes they cross once. It's even possible for them to not cross at all, in which case we'd say there is no solution. All right, but in this case there is a solution. What are the coordinates of that answer?
4, -3.
Yep, 4, -3. All right, for solving this one, again, we're going to solve it by graphing both equations. So let's just start walking through how each of these will get graphed. On the first one, the -1 moves it to the right 1. The -5 moves it down 5. So put my first point, right 1, down 5. And then from there, we're not actually going to go up 1 over 1. Because the 2 here represents a vertical stretch. Now it's a vertical stretch, so I'm still going over the same amount. So still going over 1, but instead of going up 1, I'm going up twice as far. So I'm going to go over 1 and up 2 on both sides to make my V. And of course, just keep plotting those points, and then you can draw it in accurately with a straight edge. And then for the second one, The plus 2 goes to the left 2. The plus 4 goes up 4. So I go left 2, up 4, plot the point. And then the negative out front tells me that instead of going over 1, up 1, I'm going to go over 1, down 1 on both sides. So in this case, my V is opening downward. Draw both of those graphs in. This should be what you're looking at. Now, being able to see the graphs, I can now talk solutions. So the solutions, of course, are where they cross. So I have one of them right here. So I grab the coordinates of that point. So it looks to me like it's at -3, +3. So -3, 3. Remember, x then y every single time, or in other words, over then up. The other point, the other solution here is right there. That's going to be at 3, -1, because we go right 3 and then down 1. So then those are both of our solutions. And notice every single time I'm including the x and the y as a coordinate pair.